Hello everyone! Welcome back to the channel. Today we're diving into the world of AC voltage measurement by interfacing the ZMPT101B voltage sensor with Arduino. By the end of this video, you'll learn how to build your own AC voltmeter, visualize waveforms using the serial plotter, and calculate RMS voltage accurately. Let's get started. The ZMPT101B is a voltage sensor designed to measure AC voltages up to 250 volts. It outputs an analog signal proportional to the input voltage. Important notes: always handle high voltage with caution and double-check connections. This sensor works best with 50 or 60 Hz AC signals, which are common in household power supplies. The sensor has 3 pins: VCC for 5-volt power from the Arduino, GND for ground, and out for the analog signal, which connects to pins like A0 on the Arduino. First of all, you should install the Arduino IDE software on your computer. It is a user-friendly software for programming these kind of microcontroller-based development boards. To build this project, you'll need an Arduino Uno or Nano, a ZMPT101B voltage sensor, a 1 megaohm resistor for adjusting sensitivity, a breadboard, jumper wires, and a computer with the Arduino IDE installed. Connect the ZMPT101B's VCC pin to Arduino's 5-volt pin, GND to Arduino's ground, and the out pin to analog pin A0. Add a 1 megaohm resistor between the sensor's 2 input pins to adjust sensitivity. Important safety note: never connect the sensor directly to high voltage without proper insulation. Upload the first code to visualize the AC waveform. The code reads the analog input from pin A0, applies a calibration factor, and prints voltage values to the serial plotter. The calibration factor, set to 0.56 here, adjusts the sensor's output to match real-world voltage. You'll need to calibrate this value using a multimeter for accuracy. The second code calculates the RMS voltage for accurate measurements. It samples 1,000 readings, squares each value, averages them, and then takes the square root. This RMS method ensures precise AC voltage readings. The code prints the final RMS voltage to the serial monitor. Always calibrate the sensor using a multimeter to ensure accuracy. Handle high voltage with extreme caution and use insulated wires. To stabilize readings, add a 1 megaohm resistor and a 0.1 microfarad capacitor between the sensor's output and ground. Avoid connecting DC voltage to the sensor, as it can cause permanent damage. Remember, RMS voltage calculation is critical for true AC measurements, not peak values. To measure RMS voltage accurately, sample the sensor's output 1,000 times over a few AC cycles, square each sampled value, average them, and take the square root of the result. This process eliminates noise and provides the true RMS voltage. Adjust the calibration factor in the code until the Arduino's output matches a true RMS multimeter. Note: the sensor's output may have a 2.5 volt DC offset, which you can subtract in the code for better accuracy like you see on screen. In this code, 512 is the midpoint of 0 to 1023. This value must be subtracted from the raw value to remove the 2.5 volts offset. And there you have it! You've built an AC voltmeter using Arduino and the ZMPT101B sensor. This project is perfect for energy monitoring systems or DIY power meters. If you enjoyed this video, please like, subscribe, and hit the bell for more tutorials. Let me know in the comments what you'd like to see next. Stay safe and keep tinkering.